Struggling to get clean, reliable tests in your TypeScript Node.js project? Want to master unit testing, mocking, and API integration tests the right way? In this video, I will take you through the ultimate setup from configuring Jest with a TypeScript and ESLint to writing powerful tests that cover everything from simple functions to real HTTP requests using Supertest. Whether you're just starting with the testing or looking to level up your skills, this guide will help you build confidence in your codebase with every test you write. Hi, my name is Alex. I'm a senior software engineer with years of experience in JavaScript and Node.js. My goal is to help you become a confident and stress-free developer by increasing your skills and proficiency. Let's get started. I am in an empty folder, so let's initialize our Node.js and Express app by typing npm init-y. The code for this video will be available in the Git repository, so check out the description. Now let's install TypeScript packages: TypeScript, ts-node, types for node, and ts-config node20 base. ts-node package will let us run the TypeScript directly in the node without pre-compiling. ts-config node20 base is a base configuration file we will be extending since currently node20 is the latest LTS or long-term support version. Next, we'll run npx ts-init, which generates a ts-config.json file. Let's open it, delete the default content, and paste in our own configuration, which extends node20 base ts-config. This setup includes compiler options, outputs to a dist directory, and specifies that will include files from the src directory while excluding node modules and dist. Now, let's install Jest, ts-jest, and types for Jest, all saved as development dependencies. We'll then create jest.config.mjs file with the settings to use the ts-jest preset. Specify the test environment as node and set up testing for files with the src test directory. We'll also configure Jest to recognize .ts files. Next, we'll create utils.ts file in the src folder with some utility code, followed by a test for it in the tests folder. In the package.json file, we'll add scripts to run the tests in standard and watch modes, and then we'll run npm run test to verify everything is working. With testing set up, let's configure ESLint and Prettier. First, ensure you have the ESLint and Prettier extensions installed in VS Code. You can also enable format on save in the editor settings for automatic code formatting. In the terminal, run npm init at ESLint config to configure ESLint. We will want to check syntax and find problems. The module type will be common JS. There will be none for frameworks. Does your project use TypeScript? Yes. Where does your code run in Node.js? And install dependencies? Yes. After installing our dependencies, ESLint's configuration, eslint.config.mjs file is automatically generated, but we're going to update it shortly. Now we're going to install the dependencies to integrate Prettier with ESLint. You don't have to integrate Prettier with ESLint, but I prefer doing so. Let's install the following dependencies: ESLint plugin Prettier, ESLint config Prettier, and Prettier itself, using --savedev. Before we proceed, note that ESLint uses a flat config file and not all plugins fully support it yet. First, let's open the package.json file, scroll to the bottom, and add the following configuration. We will override the ESLint version, ensuring it matches the version of ESLint we're using. In our case, it's 9.12.0. If your ESLint version is different, adjust the override accordingly. After saving the package.json file, we can go ahead and install the Prettier plugins. Next, let's update eslint.config.mjs file. Delete the existing configuration and replace it with the following code. Now let's break it down. ESLint configuration may look a little bit different to what you are used to because it uses the new flat config format. It exports an array where you can define configuration as objects. Each configuration object applies specific settings depending on the type of files and the rules needed. ESLint combines all the configuration objects, allowing those placed later in the array to potentially override the settings of the earlier ones. Let's walk through the configuration objects. The first object ignores the dist directory. The second applies rules to the src folder, focusing on JS and TS files. The next object applies common JS specific rules. Another object configures globals for Node.js like require and module. Then we use plugin like ESLint recommended for JavaScript and TypeScript ESLint recommended for TypeScript. We also configure jest-specific rules for test files in the src tests folder, adding the jest recommended rules and disabling jest prefer expect assertions rule. Next, we add custom rules. Here, we disable a TypeScript ESLint no unused vars to prevent linting errors related to unused variables in TypeScript. We also configure prettier to handle automatic fixes for end-of-the-line differences with a end-of-the-line auto. You may adjust these rules depending on your needs and add your own custom rules. Finally, we include ESLint plugin prettier recommended, which applies prettier formatting rules and ensures ESLint integrates with prettier. It's important to place this at the bottom of the configuration to ensure it overrides any conflicting settings. Next, let's go back to the package.json file and add a script for linting. Save the changes and run npm run lint. Looks like we encountered an error indicating that the jest plugin is missing. To fix that, let's install ESLint plugin jest with npm install ESLint plugin jest --savedev. Once that's done, run npm run lint again. You might get a warning about TypeScript version compatibility, but it's nothing to worry about. ESLint will catch up with the newer TypeScript versions. So what is unit testing? Unit testing is a software testing method where individual units or components of a program are tested in isolation to verify they work correctly. These tests are typically automated and focus on a small, specific pieces of code, such as functions or methods, ensuring they return the expected output for given inputs. Unit testing helps catch bugs early, improves code reliability, and makes refactoring safer. In this video, we're going to cover rather simple examples where an SUT or system under test doesn't really have dependencies, or dependencies are easy to simulate. For more advanced unit testing techniques where you have to use mocks, please check out our next video. I am in Node.js Express Task Manager API project. Let's write some unit tests for it. As usual, the link to the code is in the description below. In the tests folder, we initially wrote a simple test to prove everything was working. Let's create more meaningful tests. Usually, the low-hanging fruit and easy tests to write will be your utils functions. Utils functions in most cases are pure functions, meaning they always return the same output for the same input, meaning they are deterministic, and have no side effects. They don't modify external states such as variables, database, or UI. For example, function add in utils.ts file is a pure function. Another pure function is getErrorMessage. This function returns error message from different types of inputs like an error, an object, a string, etc. Let's write some unit tests for it. In src test folder, let's create utils.test.ts file. In this file, let's import getErrorMessage from @utils. Earlier, we added path aliases to our project and tests, therefore we can use @symbol for imports. If you want to learn how to do it, please check out this video. Let's call describe function and pass it the description of our test, in our case getErrorMessage, and a callback function. In this callback function, let's call another function test and pass it a name of the test. Should return message from an error instance. Let's define an error with a message something went wrong. Now we can do an assertion using expect. We will expect the returned message to be something went wrong. If you are new to Jest, I suggest going to the Jest documentation page where you can find a reference for expect and matchers. These will be your bread and butter when writing tests, so be sure to check them out. With that foundation in place, let's move on and create another test. Should return message from an object with a message property. In this case, we'll define an error as an object with a message property, and just like before, we expect the getErrorMessage function to return the correct message string. There are a lot more test cases to write for this function, but you can cheat and just ask ChatGPT or whatever IDE AI plugin you have, like a Copilot, to write tests for you. AI does a pretty good job at writing tests. Meanwhile, let's run npm run test to make sure our tests work. But before we do that, if you find this video helpful, please hit the like button and subscribe to our channel for more videos like this. After running npm run test, we can see that our tests are passing. Another function that we have in the utils.ts file is getPagination parameters. This function is a bit more complex because it takes an express request as a dependency, so we'll have to do some work to simulate it. In the utils.ts file, let's import request from express config from add_config and getPagination parameters function from add_utils. Let's describe our set of tests as getPagination parameters and pass a callback function. In this function, let's write a first test should return default values when page and per page are missing. We're going to create a request object with empty query and cast it as express request and make an assertion that we expect getPagination parameters function to output default pagination parameters when the request is passed to it. The second test we will write is called should parse valid page and per page values. We will create a rec object with a query parameters page equals 2 and per page equals 20. Sometimes TypeScript will complain if you cast an object to express a request directly. So first you may have to cast it to unknown and then as request. We will assert that when we call getPagination parameters with the request that we just created, we will get a valid pagination parameters object. Obviously, there are more tests you can write for getPagination parameters function. I will leave it up to you to practice. We will just run npm run test to make sure the tests are passing. The next low-hanging fruit in your code can be a class that doesn't have dependencies. For example, we have task entity class. Well, this class depends on class transformer library, but this is actually what we want to test. We want to see if this class correctly marks a task as completed, sets priority level, and displays priority level as property on the DTO or data transfer object we are returning as an API response. Let's go ahead and create task.test.ts file in src tests folder. We're going to import task from add data entities task and use describe function to describe the task entity set of tests. Before calling the test function, we will first do a quick setup. We will define a mock date that is an arbitrary date of January 1st, 2025. Then we will create a task entity. We will use a new task instance in each test. Therefore, we will use before each function to create a new task with the default properties. The first test simply checks that a task instance is initialized correctly by running simple assertions on the task properties. In the next test, we will check if the task can be marked as completed. First, we make sure completed on is null. Next, we call mark as completed method on the task. Finally, we check that completed on is instance of date. To be instance of date is a better assertion than testing for a specific date because there will be some time difference from when the task is marked as completed and when we actually check completed on date. In the next test, we check if the error is thrown when marking an already completed task as completed. Since before each creates a fresh instance of a task, for each test, we can just mark task as completed. Then, in the assertion, we mark the task as completed again and expect that an error is thrown. In toThrow method, you can check for a specific error or error message, but later you may change error message or error type, so it is safer to just check if an error is thrown in general. The next test tests the logic of setting a priority level. The requirement is that if due date is within 1 day from today, the priority level should be set to high. If it is more than 1 day, let's say 7 days, the priority level is set to low. And if the due date is not defined, in other words, it is null, the priority level should be null as well. Finally, we can test that the DTO or data transfer object is created correctly. In our case, we need to be sure that created at property is excluded and priority level property is added. We create test DTO by calling asDTO method on the task instance and then check that the task DTO doesn't have property created at, but it has property priority level. We are done. Let's run npm run test and the tests are passing. Before we call it quits for this video, let me also show you how to run test coverage report with Jest. You can do it quite easily by calling npm run test -- coverage. Don't skip the first 2 dashes. You need them to pass a flag, in our case coverage, when using npm command. Jest ran the tests and also provided a coverage report. As you can see, we covered 100% of task.ts file and about 50% of utils.ts. Test coverage shouldn't be your only metric to determine good tests. From my experience, certain companies may require you to have about 80% of test coverage. As a rule of thumb, though, test the code that contains logic. If it doesn't, you may not need to test it. Think your Express API is well tested? Think again. In this video, we'll dive deep into advanced unit testing techniques for Node.js application, covering best practices, mocking dependencies, and ensuring your API is bulletproof. When building an application, our code can be represented as a dependency chain of modules. Module A depends on Module B and C. Module B depends on a library, let's say Axios. Module C depends on Module D, and Module D can also depend on a library such as Sequelize. To explore this chain, we can look at two modules in isolation. Let's say one of them is a client and the other one is a server. The client module requests some kind of data and the server module provides it. Testing the server is easy, at least in this isolated case, because it doesn't have any dependencies. But testing client is a bit harder because besides simple state tests that don't require any dependencies on the client, except for maybe standard libraries, we also need to write collaboration tests since the client depends on the server. In order to write the collaboration tests, we need to answer two questions. On one hand, does the client call the server's methods correctly, meaning the client calls the correct method with correct arguments? On the other hand, does the client handle responses returned by the server correctly? For example, if a client is asking for a collection of tasks and the server responds with only one task in that collection, does the client return back this one task or does it redirect to that specific tasks page? Or what happens if the server throws an error? Does the client handle it correctly and doesn't break? To answer these questions, we don't necessarily need the server. The server can depend on ORM and have a connection to the database. This will complicate the tests, making them slower and database dependent. So instead of the server, we can use mocks and stubs. To answer the first question, we can create a mock. A mock is essentially a server's test double that mimics the behavior or methods of the server. For example, we can create a server's mock that will have create task method. Now we can test if the client calls that method with correct arguments. To answer the second question, we will need a stub. A stub is a hard coding the mocks method to return a specific answer that is convenient to the current test. For example, the client's create task method can return a newly created task. Now we can test if the client correctly handles this newly created task. As an aside, besides mocks and stubs, there is also a spy. A spy in testing is a wrapper around an object that gives information on how this object is interacted with. Unlike mock, spy doesn't replace an object. If you have a repository, a spy won't replace its methods. This repository will still interact with the ORM and database. The spy will give you the information about the interaction, for instance, which methods are called and with what arguments. I tend to use spies very infrequently. For the most part, I use mocks and stubs. Okay, so after the collaboration tests are created using mocks and stubs, there is actually one more thing that needs to be taken care of. When we use the server's create task method, there is also an implied contract. Create task method should return a new task. We stop this return for the client's test, but ideally we also need to be sure that when we test the server's create task method, it actually returns a new task. These contract tests can be hard to write because you will need an actual clean database to make sure the task is created and returned by the server. If you are dealing with a third-party API that you don't have control of, these contract tests may be even impossible to create. In reality, with the third-party integrations, most of the time you will have to assume the contract will be respected. I hope now you can see the pattern here. If the server depends on another module, now the server becomes a client and that other module becomes a server, and you write the state and collaboration test for the new client previously known as a server. And so on and so forth till you reach either a module that doesn't have any dependencies or depends on a third-party library like Sequelize that doesn't need to be tested since this library was already tested by its creators and maintainers. Okay, let's see how it looks in practice. I am in Node.js Express project. This is a task manager API that we have been building. As usual, the link to the GitHub repository is in the description below. In src routes v1 tasks controller.ts file, we have a function createTask. This function instantiates createTask use case with request and mailer and calls execute method on it. The result is then returned back to the user with the status 201 in JSON format. Let's see how we can test this function. In src test folder, create task controller.test.ts file. In this file, we will import request and response from Express, mailer from services mailer. We will also import create task use case from use cases and create task function, the actual function we want to test, from the controller. Since the create task function depends on create task use case, we need to mock it. We will mock the mailer as well because we pass it to create task use case when instantiating it. Let's describe create task function. In the callback function, let's define rec and res as partial types of request and response types respectively. Execute mock is a mock for the execute method on create task use case. JSON mock and status mock are mocks for the methods status and JSON on the response. This way, we will check if the client is handling the server's response correctly. In our case, if we're setting the correct status and sending the correct JSON back to the user. After assigning the types, let's create before each function and define rec, res, execute mock, JSON mock, and status mock. Rec will have the body and the auth properties. The body will contain the payload for the task to be created. JSON mock is just a mock responses JSON method. Status mock is a mock of a status method that will have the JSON mock chain to it. Execute mock is a mock method that will be called on create task use case. Besides testing that this method is called correctly, we will also need to test if the response from that method is handled correctly. As we mentioned before, we will need execute mock to return a stub. Our stub is a task object with an ID of 1 and the name new task. Since execute method belongs to create task use case object, we will need to mock implementation of the execute method by assigning execute mock to the execute property. Finally, we are ready to write a test. As you may have noticed, you will need to be pretty good at mocking, so be sure to check JS documentation to learn how to create mocks. And as usual, feel free to ask ChatGPT for help. It does pretty good job at mocking. Let's create test function should create a task and return 200 with the task data. Inside the callback function, we will call create task function of the controller with rec and res arguments. Now we will use several assertions. We will expect that create task use case was called with a rec and mailer object. Essentially, we're testing if create task use case was instantiated with the correct arguments. Next, we test if execute mock, aka execute method, was called on create task use case instance. These two assertions make sure we call the methods correctly. Now we need to make sure we handle the response correctly. We will do that by expecting that status mock was called with a 201 created status, and the JSON object has a task property that is assigned to an object with a task ID and a task name. Let's run npm run test to make sure the test we wrote is passing, and it does. Now we need to test the dependency of the create task function, create task use case, and in particular its execute method. Let's take a look at create task use case class. The execute method uses the repository to create a task and the mailer to notify an admin that the task is created. So, to test this method, we will have to mock the repository and its create task method and the mailer and its send method. We will create a stub for the task created by the repository since it is used by the mailer. We will also make send method of the mailer to throw an error to check if it is handled correctly. Let's create task use case.test.cs file in src test folder. We're going to import create task use case from use cases, request from Express, iMailer interface, repository, config, and logger. Next, we're going to mock repositories create task method with a jest mock. We will also mock the error method of the logger to check if it is called if the error is encountered when attempting to send a notification email. Now we can call describe function to describe create task use case. As before, we will mock rec and mailer objects in before each function since we will need them to instantiate create task use case. Let's create a test called should create a task and send an email. In the async callback function, we will first create a stub for task data and make sure repositories create task method returns it. Next, we will instantiate create task use case and call its execute method. Finally, we will assert that create task method has been called with a request body and an authenticated user ID. The mailer is called with an appropriate object, and the result equals to the created task data. In the next test, we will check if an error is logged when an email notification fails. Again, we will define task data and mark it as a response of create task method. We will also mark a rejection value that mailer's send function returns as an error. Sometimes TypeScript gets in the way of tests, so not to get in the weeds of figuring out what it doesn't like about our test code, we can simply have comments at test expect error above the code lines that cause us problems. After instantiating the create task use case and calling execute function, we will expect the logger's error method to have been called with a mail error. Let's check if the tests we wrote are passing. This time we will run npm run test --watch to start Jest in watch mode. This way Jest will be watching for changed files. You should be running it this way when developing. Finally, let's write a test for the mailer. Let's open mailtrapmailer.ts file in services mailer mailtrapmailer folder. Mailtrapmailer class uses node mailer library that will need to be mocked. The transporter is initialized in the constructor function. The send method uses the sendMail method on the transporter to send an email created for an object passed to sendMail. Let's create mailtrapmailer.test.ts file in the src tests folder. We will import node mailer, config, mailtrapmailer itself, and iMail notification interface. We will define sendMail mock to return email sent successfully mock. Also, we will mock node mailer's create transport method and assign sendMail mock to sendMail. Let's create describe function to describe mailtrapmailer tests. We will create a new mailtrapmailer before each test, and after each test we will clear all the mocks. Now let's create the test itself. We are testing that mailtrapmailer should send an email with the correct parameters. First, we define mail notification object. Next, we call send method on the mailer with a mailer notification object. Finally, we will do a few assertions. We will assert that create transport was called with the correct configuration parameters, that the sendMail method, or actually its mock, was called only once, and that it was called with the correct object. After saving the file, Jest Watcher detected the changes and reran the new test. Everything is passing. And there you have it. By creating state and collaboration tests as well as contract tests where possible and moving up the dependency chain, you can write a solid set of unit tests for your project. If you are building APIs with Node.js, writing reliable and maintainable tests is a must. And today, I will be showing you how to do it the right way. We'll be using Jest, the fast, flexible testing framework trusted by top developers, and Supertest, a powerful tool that makes HTTP request testing a breeze. Before we begin, here's a quick outline of what we will do. First, we'll start by installing Supertest along with the TypeScript types, so we have everything set up to start writing integration tests. Next, we will write a simple test to get familiar with the workflow. We will test the health endpoint using Supertest to make sure everything is wired up correctly. Then we'll move on to a more realistic example. We'll test the create task endpoint by mocking the underlying use case and checking that the response behaves as expected. Along the way, we will deal with authentication middleware. I will show you how to bypass it during testing so it doesn't interfere with our integration tests. After that, we will simulate an error in the create task flow to test our error handling middleware and make sure it returns the right status code and message when things go wrong. We'll also cover request validation. I'll show you how to write a test that checks what happens when required fields like the task name are missing from the payload. And finally, we'll run test coverage report to see how our integration tests contribute to overall coverage. Even just a few tests can make a big difference. I am in Node.js Express API project. Earlier we talked about how to write unit tests for it. Although your unit tests will be the bulk of your testing, you will also need integration tests. Integration tests are helpful in various situations, and especially in testing middleware, because middleware work as an interceptor for HTTP requests, and this interaction can be hard to test using unit tests. So to do integration tests, you will basically need to automate making requests into your API and make assertions very much like we did with unit tests. A great library for that is Supertest. Let's install it with npm install supertest and a type supertest with a savedef flag. In order for Supertest to make a request, we need to give it an express app. If we look at server.ts file, we can see that create server function returns an express app. Also, this file has a simple health route. Let's test this route to get our feet wet with a Supertest. In src tests folder, let's create integration tests.test.cs file. We're going to import Supertest and create server function from server.ts file. Let's describe our tests as health endpoint tests. Then we call test function and pass it health endpoint returns OK to 100. In async callback function, we will call Supertest with a wait and pass it express app by calling create server function. We will make a request to health endpoint with a method get. We will expect 200 response, status, and OK property of the response body to be true. This is as simple as it gets when you use Supertest. Let's start jest in watch mode with npm run test --watch. The test is passing. Let's write more complex tests. In routes v1 tasks controller, we have a function create task. It instantiates create task use case and calls execute method on it. The response is returned to a user with a status 201 and JSON body with a created task assigned to a property task. In the previous video, we wrote unit test for this function. Let's write the same test using Supertest. In integration test.test.cs file, let's import create task use case. We will also mock it because we are not interested in going all the way through and creating an actual task. This will require us hitting the database. When running automated tests, most of the time you won't have the database available. The automated tests should be quick. Let's describe create task integration tests. First, we will create execute mock. This is the mock for execute method on create task use case class. By default, we will resolve the returned value to null. Before each test, we will assign execute mock to execute property on the mock's implementation of create task use case. After each test, we will clear the mocks. The test itself will be it creates a new task. In the async callback, we will update execute mock to return a new task object with an ID of 1 and name new task. We will then call Supertest and pass it an express app, the same way we did earlier. We will make a post request to v1 tasks endpoint with a payload object containing name property and value new task. We will expect to receive 201 created status. We will add a couple more assertions to expect the response body to have property task. This is basically what we're after. We need to make sure the response is returned to the user in the correct format. We will also check that the task name is new task, making sure create task function doesn't transform the output of the execute method of create task use case. After we save the file, it looks like the test is failing with a 401 unauthorized error. This is because we have authenticate user middleware that is applied to the route. In order to make this test work, we need to turn off the middleware. Let's use jest mock with a callback function that sets isModule to true and assigns default export to return a middleware function that passes through the request. Now everything works and the test is passing. Great. The next thing that we can do is to test if we have a correct response when things go sideways when creating a task. Create task function of the task controller doesn't handle errors. Errors are handled in the error handler middleware. Therefore, it may be hard to test error handling with unit tests. That's where we can make our life easier and use integration tests with a Supertest. Let's take a look at error handler middleware. It handles different types of errors such as validation, custom, and unauthorized. At the end, the middleware handles an error that doesn't belong to any of the types above. It sends a response with a status 500 and an error object with an error message. Let's write a test for it. In integration test.test.cs file, let's create a test. It returns an error when trying to create a task. We will make execute mock to mock rejected value of an error with the message error creating task. This is essentially the same as throwing an error from the execute method of create task use case. We will make a post request to v1 tasks with a new task payload and expect the response to have 500 status. We will also write an assertion that response body contains property error. After we save the file, we can see that the tests are passing. The next use case where Supertest is helpful is for testing request validation. In this project, we use validate request middleware that in turn uses Joy object schema. The schemas are defined in src data request schemas.ts file. Create task schema uses the task object that defines Joy validations. According to these validations, the task name is required. If the task name is missing or any validation fails, for that matter, the validate request will throw an error that will handle in error handler middleware as validation error. The error handler will respond with a 422 HTTP status, an error object containing message, error code, error valid, and mapped error messages. Let's write a test for that. The test will be it validates task's payload by requiring a task name. We will use Supertest to make a post request to v1 task's endpoint with a payload containing only the description of the task. We will expect to get 422 response status. We will assert that the response body contains an error object with error code error valid. Let's save the file. The jest watcher reruns the tests and we can see that they are passing. Finally, we can run coverage report with npm run test -- coverage. Although we only wrote a couple of integration tests, our test coverage increased significantly. This is because by definition, integration tests touch several modules. I'm usually a bit careful with integration tests because they can provide a false sense of security. Bulk of my tests are unit tests, and I usually use Supertest to test middleware and use cases where I have redirection in my code. I think integration tests are very suited for that. After you test your project, it is time to deploy it. If you want to learn how to deploy a Node.js and Express API, please check out this video.